и нашия track record, ако мога така да се изразя с английската дума, от всички програми, които сега ще ви представя, доказват обаче, че един от основните и най-ефективните начини да се подкрепи създаването на комерциален продукт, само един момент, извинявам, е де-факто да се създадат иновационни програми, които да подкрепят създаването на идеи за използване на тези данни като с комерциални цели, ако обича следващия слайд, и да се създаде една верига от съпортващи програми, която да подкрепи хората на науката, които идват с много добри идеи за използването на тези данни и да ги подпомогне да създадат комерциални програми. Както виждате, това са нещата, с които ние се занимаваме от много години. Ние сме създали така наречената иновационна верига от започването на откриването на една идея, иновационна идея за използване на данни, от сателитни данни, през подкрепата на тази идея за нейното подрастване и озряване, до инкубацията на потенциални идеи, които създават нови фирми, като стартъпи, до акселерирането на стартъпите и така нататък. Тоест, тези четири различни периоди, които виждате на екрана, от създаването на идеи в рамките на хакатони или AppCamps, продължаването на тези идеи в следващото ниво за участието му в иновационни конкурси и състезания, влизането им в акселератори и инкубатори и до инкубирането им като стартъпи. Това е целият така наречения deal pipeline, който ние с най-голямо удоволствие не само създадахме в последните много години, но и подкрепяме и до днес с нови инициативи и нови програми. Ако обичаш следващия слайд. Бих искала да започна от първата част на тази верига, по-скоро за Space App Camps и Hackathons. Всичките, следващия слайд, моля. Всички тези програми, които сега ще видите, нямаше да съществуват, ако не бяха всичките ни институционални и комерциални партньори, с които заедно създаваме тези програми. Те се финансират основно от нашите институционални и комерциални партньори. И нашата роля е не само да създаваме тези проекти, но и също да ги организираме и да създаваме и да обогатяваме тази мрежа от интернационални партньори. Започвам с една инициатива на ЕКА, на European Space Agency, на Европейската космическа агенция, която се нарича ESA Space Application Camp. И е един уникален ивент, който заради COVID-19 кризата в момента за пръв път ще се проведе тази година само по виртуален път. Останалите, ако опинеме на следващия слайд, ще видим, този ивент се осъществява от 2012 година, всяка година през септември. И до тази година беше един уникален ивент за покана на 20 избрани програмисти и девелопери, които да посетят ИЗА в Разкати, в ИЗА Есрин и заедно да създадат идеи в този мобилни апликации или mobile apps, които да използват Sentinel данни от Copernicus програмата. За тази година, както споменах, за съжаление, ивента ще се състои само виртуално. Все още е отворен срока за кандидатстване и аз бих искала да призова всички, които слушат тази презентация, а дори и да не слушат, може би някои от вас имат идеи за препоръка на български програмисти или хора в тази сфера, които имат интерес да се включат. Въпреки че ще бъде виртуален ивент тази година, това е едно уникално събитие, подкрепено и създадено заедно с Европейската космическа агенция и с най-голямо удоволствие искам да ви поканя да отидете на сайта, който виждате тук в кръгчето Sign Up. До 14 август може да се кандидатирате за този ивент. Ако минем на следващия слайд, бих искала съвсем накратко да ви представя победителя на Space AppCam от миналата година. Това беше един норвежки тим, който се е създал първоначално по повод на един друг ивент, Cope4BG2020. Това беше един ивент миналата година, може някой от вас да си спомнят, в Румъния, също с участие на Европейската космическа агенция и с подкрепата. И в рамките на този ивент също имаше едно иновационно състезание на Европейската космическа агенция и този норвежки тим успя да вземе първата награда още тогава. След това младежите дойдоха на нашия Space AppCam и се състезаваха с останалите 20 програмисти на тази тема и успяха отново да се преборят. И тяхната апликация е свързана с рибарниците и с контролирането на квотата за риболов в северните морета, като те използват Copernicus Sentinel 3 данни и ги комбинират с други данни, визуализират и помагат контрола на риболова или по-скоро на квотите за риболов в океаните и моретата. Както виждате, една много интересна тема, която потенциално може също да е релевантна за Черно море. Така че отново призовавам всички, които имат желание да се включат в тези иновационни програми, имат възможността и при положение, че е виртуален ивент, могат да се включат в това състезание. Следващия слайд, моля. Това е втория голям проект, който ние организираме и ръководим, за който в България, благодарение на нашите партньори от технологическия трансфер офис, които организираха вече 2 хекатона в София с други партньори. Разбира се, аз не искам не мога всички да ги спомена, но изключително съм благодарна, че България беше много активна в Коперникус хекатона и още нещо да се отбележи. България беше първата страна, която направи също един напълно виртуален Коперникус хекатон, изключително успешно по време на кризата, още докато всички бяхме приковани в къщи. Катя Димитрова ще ви представи по-детайлирано по-късно в ивента резултатите и от българските Коперникус хекатони. Ако минем на следващия слайд, искам само да обобща за какво става дума. Това е една програма на Европейската комисия, напълно финансирана програма от комисията. Идеята е да се окуражат млади и не толкова млади хора с интерес в най-различни сфери и да се окружат и да се подкрепят за използването на сателитните данни от Sentinel и Copernicus програмата за по-голямото разпространение на Коперник. Общата програма продължи 2 години. За рамките на тези години ще се организират 40 хекатона из цяла Европа. Към тази дата програмата завършва през ноември тази година. До края на програмата, до ноември, ще имаме приблизително 2000 участници във всички хекатони, което е наистина много окуражаващо. И всъщност това, което е най-интересното, е, че тук Европейската комисия предоставя кофинансиране за организация на тези хекатони и подкрепя и с други възможности местните организатори. Ако минем на следващия слайд, ще видим всички страни, в които са организирани хекатони до сега и останалите няколко хекатона се очакват тази есен. Те ще бъдат всички виртуални. Но както виждате, наистина покритието на тази инициатива е много голямо и ние сме изключително горди, че бяхме в състояние с толкова голям ентусиазъм от всички локални организатори да създадем и да организираме една програма, която наистина показа невероятни резултати в тази първа сфера, която споменах, в първата сфера за създаване и подкрепене на идея за използване на данните на Коперник. И както споменах, RIC Space Transfer Technology Transfer Office е нашият централен партнер за България и Катя ще ви разкаже малко повече за това по-късно. Следващия слайд, моля. Идваме към следващата група от иновационни програми, така наречените иновационни конкурси. Следващата. Това са двете флагшип имена, както ние ги наричаме, на Галилео Мастерс и Коперникус Мастерс. Нека с две думи да ви разкажа няколко исторически данни. Галилео Мастерс е вече повече от 15 годишен и както чухме в презентацията на колегите от GSA, темата Галилео е по-отдавнашна, защото проектът е по-стар, като се сравни с Коперник. Но при всички случаи нашето състезание или нашия конкурс се започна като така смела инициатива преди 15 години, преди нито един Галилео сателит е в орбита. Идеята беше тогава да се подкрепя възможността за създаване на апликации и услуги, използващи сателитната навигация. Всички ние знаем, че сателитната навигация вече се превърна в една част от нашия живот и ние не можем да си представим живота без подкрепата на сателитна навигация в нашите GSM и смартфонс. Но при всички случаи това, което всъщност тази инициатива направи, е отвори пътя и към създаването на повече applications и услуги, използващи сателитната навигация. Ние имаме право да ползваме, това състезание се казваше The European Satellite Navigation Competition много години, докато накрая с изключителна голяма гордост бяхме изключително доволни, когато ни беше позволено да използваме Галилео бренд. Ние работиме в много твърдо сътрудничество с всички партньори, които са свързани в програмата Галилео, като се започне от Европейската комисия, GSA, ИСА, немската Aerospace Center и така нататък. Това е историята на Галилео Мастерс, ще се спреме на него след малко. Коперникус Мастерс е както споменаха, по-млада инициатива. Коперникус Мастерс е иницииран от Европейската космическа агенция преди 9 години. И всъщност това, което, ако минем на следващия след, това, което е в моментното състояние на двете състезания, както виждате, това са всички партньори на двете състезания, дали са институционални или индустриални партньори. А отдолу това, което виждате, е всичките новата инициатива на Галилео и Коперникус Мастерс от тази година, така наречените Галилео и Коперникус Prizes, които са кофинансирали отново от Европейската комисия и позволяват едно регионално участие на много от тези, за много държави в Европейския съюз и дори извън. И всъщност, ако минем на следващия слайд, бих искала съвсем набързо да премина през състезанията, за да достигнем, времето е ограничено, за да достигнем до следващите теми. Както споменах, Коперникус Мастерс е основната иновационна мрежа за комерциални апликейшени във връзка с наблюдението на Земята. Следващия слайд. Това са данните за статистическите данни от последните 9 години Коперникус Мастерс. Както виждате, изключително голям нетворк от участници и всъщност структури, които успяват да получат бенефит от цялата участието им в този нетворк. Следващия слайд. Да, отново това са партньорите за 2020 година и регионалните партньори, които участват. Ако минем на следващия слайд, ще видим кой всъщност спечели Copernicus Masters миналата година. Това е една много интересна млада фирма, която продължава да бъде подкрепена от следващите, от други програми в подкрепата на Copernicus Innovation. Green City Watch спечели не само челенджа на Planet, но и стана цялостния победител на Copernicus Masters миналата година. Следващия слайд, моля. Искаме се да преминем през Galileo Masters по същия начин. Ако просто за да разберете какъв е фокуса и каква е разликата между двете. Ако минем на следващия слайд, просто можем едно след друго, относно статистическите данни. Да, следващия. Тук, като минем на следващия слайд, ще видите, че страните, които участват в Galileo Masters са повече. Това ще се промени за следващата година и аз с най-голямо удоволствие очаквам интереса на България да продължи, за да може да поставим и знамето на българското знаме сред всички тези знамена. Ако минем на следващия слайд, ще видим победителя на Galileo Masters от миналата година и аз предполагам, че тези слайдове ще бъдат възможно да се даунлоудват в последствие, така че ви препоръчвам ако имате желание и повече информация за всички тези неща, да погледнете слайдовете след презентацията и след ивента. Последният слайд за двете конкурси е изключително важен, защото той показва каква е мрежата, която тези две състезания създават в продължение на последните 15 години. И тази малка диаграма, която е в дясното, виждате какви структури са включени като партньори в двете състезания, които всъщност подкрепят имплементацията на състезанието в различните страни. И това е нещо, за което наистина, както споменах, много се надявам, че България ще бъде включена в тази карта за година. Следващия слайд преминаваме на още една тема. Какво се случва с най-добрите идеи от тези състезания? Те преминават в акселератори и инкубатори. В конкретния случай ние организираме тази година така наречения следващия слайд, Galileo инкубационна програма, която е най-голямата инкубационна програма за сателитна навигация. Ако минем на следващия слайд, ще видим какво дава този инкубационна програма. Това са допълнителни възможности за финансиране на най-добрите идеи от Galileo Masters. И както виждате, тази година топ 12 от Galileo Masters ще имат възможността да се борят за 6 места в Galileo Incubation. С това искам просто да обърна внимание, че целият инволвмент на иноваторите и на всички, които се включват в тези състезания, не се свършва с самото състезание, а продължава нататъка в допълнителни програми, които се заслужават да се проследят. Ако минем след това, минаваме на още един интересен проект, който ние имаме от повече от 10 години. Това е бизнес инкубационните центрове на Европейската космическа агенция. Ние специално се занимаваме с инкубация, локална инкубация в Бавария и в Германия, отскоро и в Северна Германия от 15 години. И виждате, ние сме най-големия бизнес инкубационен център в Европа с повече от 175 стартъпи, които са преминали през нашите редици и са получили подкрепа в нашия ИСАБИК, както така се нарича. Това беше третата част и последната част, но аз все пак реших да ви обърна внимание на още два интересни проекта, които в момента са актуални. Преди да го направя отново, иска ми се да кажа 2-3 думи за тази за тази верига от различни активности. Идеята на цялата това нещо и този съпорт, който се оказва от институционално финансиране и подкрепа на индустриални партньори, е не само да се открият потенциални добри идеи за комерциализация, но и да се подкрепят във времето им да се създадат истински комерциализиране на тези идеи. Така че, ако имате идеи, ако имате желание да опитате и да се включите в тази мрежа и в този нетворк, може да се обърнете не само към мен лично, а и да отидете на всички страници, които бяха представени тази презентация. И накрая, само съвсем накратко, още два R&D проекта в рамките на Horizon, ако минем на последния слайд, Other Relevant Projects. Това са два проекта, които АЦО също участва много активно. Първият проект и двата са от Horizon 2020. Първият проект е свързан с земеделието и също е един невероятна възможност за финансиране, защото всъщност на тези два линка, които виждате на този слайд, ви призовавам да се информирате относно възможностите за финансиране на проекти, които обаче се занимават с проблеми, свързани с земеделието. В момента до септември месец е отворен един open call за събиране на кандидати за това финансиране, така че обърнете внимание на този Horizon проект. И последното, което искам да ви обърна внимание, е така наречения Opetus Mundi проект, който е той има доста, но още един опит да се създаде една отворена платформа за дигитален пазар за индустриална Geospatial Data Assets. Това е един проект, с който ние също подкрепяме и сме част от консорциума. Това бяха в краткото време за днешната ми презентация. Това бяха основните неща, които исках да ви разкажа. Отново ви призовавам да се свържете с мен. Аз имам след предишния ивент на нашите партньори от Технологически офис преди време, преди няколко месеца, получих доста директни въпроси, за което благодаря. Ако всички хора, които се свързаха с мен, слушат и днес, за мен е удоволствие да подкрепям българското комюнити и по всяко време може да се свържете с мен, както и ако имате въпроси сега, съм с удоволствие ще отговоря на чата. Благодаря много.
Благодарим ние също. Очевидно следващия път трябва да отделим поне един час, за да може в много повече детайли да се представят всичките тези възможности. За сега не виждам въпроси в Q&A секшена, но ако такива настъпят в последствие, те разбира се ще бъдат изпратени до презентаторите. Благодаря отново. И тъй като времето вече доста напредна, so I would like now to give the floor to Mr. Daniela Vandenbroucke, who will present the EO4Geo projects, Earth observation, geographic information, and in different areas of education. Mr. Vandenbroucke, would you please start your presentation?
Thank you. Can you hear me?
Yes, very well.
Now we will show my screen. Okay. Do you see my major screen now?
It's the screen with some notes.
Okay.
Screen. Yes, now it's okay.
Okay. Okay. Thank you. Thank you so much. And thanks to the organizers of this event to invite EO4Geo to present the project. I will briefly walk through some slides that provide an overview of the project. I'm Daniela Vandenbroucke from the University of Leuven in Belgium and a partner in the project. I will have a very brief introduction how EO4GEO fits in the Copernicus ecosystem. And of course, then I will give some overview on the project itself. So it's a Sector Skills Alliance under the Erasmus Plus program. And then I will zoom in on two aspects that are quite important within the project. It is the creation of what we call an ontology-based body of knowledge for the GI and Earth observation sector. And the way we design curricula using some tool sets for matching or for developing better skill sets. And then I will end on the long-term strategy which we are building and the role of the network of networks within this construct. EO4GEO is not an isolated project. In fact, it is it makes part, or it is part of the broader Copernicus ecosystem. Already in the previous presentation, you heard about the role of different Copernicus initiatives. Of course, we have the Copernicus Academy, the Copernicus Relays, two networks, the Copernicus Masters, and so on. But there are particular initiatives related to Copernicus skills or skills development. In that context, EACA, the agency for the Erasmus Plus program, has initiated for various sectors projects and support projects to develop what we call strategic approaches for blueprints for each of the sectors. And EO4GEO fits well in there because it takes care of the space and geographic information on the geospatial sector. You have also other sectors are covered by EACA, defense, automotive, textile, and so forth. But EO4GEO is the one that focuses on space and geospatial and fits entirely in the Copernicus ecosystem. Some key figures on EO4GEO. The project takes 4 years, started already in January 2018, is almost 3.9 million euro, funded by Erasmus Plus, although the budget is a little bit larger because there's co-funding also. 26 partners are part of the consortium, and there are currently 34 associated partners covering the whole of Europe. The partners are from academia, the public sector, private sector, are different networks involved. And we have multiple coordinators. The general coordinator is from Italy, GISIC. KU Leuven, my university, is the scientific and technological coordinator. University of Salzburg is the education and training coordinator, and we have a very important track on exploitation and long-term sustainability, and that's covered by Climate KIC, one of the KICs active and also very active in Copernicus. We have in one sentence, we try to summarize the goal of EO4GEO. We want to evolve towards an innovative strategy for permanent or continuous skills development and capacity building for the sector to improve and to support Copernicus user uptake. That's, let's say, the overarching goal. Now, what we do is multiple things. We first, in the first year and part of the second year, we focused on the development of a sector skills strategy, including recommendations on how to respond to skills mismatches and shortages in the sector to improve the uptake. Linked to that is the last bullet, in fact, that will evolve towards what we call a long-term action plan, because the aim is not to stop after the 4 years, but to really roll out and to sustain the proposed solutions, the tools, everything, in fact, the whole methodology. As part of the activities, we develop an ontology-based body of knowledge for the sector, describing our field, in fact. I come back to that with a few other slides. We also develop a collaborative platform and especially a set of innovative tools, several ones to support skills development like curriculum development, job profile, offering, etc. We also design a series of curricula and a portfolio of modules that is relevant for Copernicus, but also other programs. And we develop also, and we offer a series of training actions in 3 subsectors: the integrated applications, smart cities, and climate change. And there, in these actions, we test and validate the approach. That's basically the idea. So what is this skill strategy? We start, and all the sectors are doing the same, what we call skills. We develop skills intelligence. It's in fact an approach and a user-friendly set of data, information components, facts, assessments, the interpretation about what happened in the past, the present, and what is probably the future skills requirements in our sector. So usually the focus is therefore on, and we did several studies, on what is currently offered in the field at the education and training level. So we documented more than 1,100 training modules from academic till vocational training, different types. We zoomed in on the current demand for GI and Earth observation skills and occupational profiles. We assessed the technological and non-technological trends and the related challenges and opportunities for the sector. And then we assessed the shortages and the gaps or the mismatches between the supply and demands. And based on that, we made a series of recommendations and a first version of a skill strategy, which we are currently transforming into a second document that is meant for broader consultation at the public level. What do we speak about when we speak about technological trends? For that, we work together with the Open Geospatial Consortium, which is a huge consortium of 550 academia, private companies, etc., and which cooperate on standardization, but they have a very developed technology trends watch. So we work together with them for our technology assessments. Then we zoom in a little bit on this ontology-based body of knowledge. In fact, ontology-based body of knowledge is many things, but what we do is we try to define our fields in terms of concepts. And a concept can be a theory, it can be a method, a technology, it can be an application, it can be many things, but usually the technologies and the concepts are interrelated. For concepts, we can refer or can be used in training modules. We can refer to references, can be books, it can be a training module, it can be other things that have one or more authors. So concepts are described while also related skills are defined, usually in terms of learning outcomes, and then references can, as I said before, be many, many things. It is scientifically based, but also very practical. So it's not only about the theory, it's also about the implementation and the application of the technologies, etc. And of course, it tries to cover the professional domain, but what is the professional domain? Let's say we cover science, technology, and applications for geographic information and Earth observation, science and technology. But of course, we know that is interlinked with many other disciplines. On the left, you see the broader disciplines like mathematics, statistics, physics, informatics, etc. Then on the right side, you see that also linked to broader disciplines like, of course, space, but also engineering, architecture, landscape architecture, geography, etc., etc. And then at the bottom, it's also closely linked to all the different application domains, whether it's agriculture, atmosphere and climate, transport and mobility, disaster and geohazard management, security, etc., etc., etc. So the book is trying to cover, of course, the core, but there is clearly a link to all these other elements. It is in the form of an ontology. What does it mean? All these concepts, you see the relationships at the right side, but we have also these descriptions, and we try to do this systematically. How do we do that? And I give just one example of a technology. Sensor web enablement is a technology used in Earth observation, but also in geospatial sector. Of course, sensors are used for in situ measurements and setups to monitor air quality, to do weather forecasting, to monitor water flows, noise, etc., etc. And of course, at the technology side, we have the web technology stack, where you have the service-oriented architecture, you have the web and how it works, W3C is coming in there. And of course, all these elements are there interconnected, and they offer a mechanism to have what we call sensor observation services. So they serve through the web all these measurements so that you can do something with it. And there is also a sensor planning service to orchestrate all these things. And of course, you need to know something about observations and measurements. And all these things are coming together because at the end, all this information is integrated in work processes and data flows so that you use tools, can be remote sensing tools, can be GI tools and applications. And this is an example where noise measurements are used and modeled to look for the impacts of noise on neighborhoods, etc. And here you see the noise of road traffic, air traffic, etc. And then we define skills related to that. And here are just examples of skills for this particular case. You want to know, and you need skills to do interpolation of observations and measurements. You need to know, or other people might need to know, how you set up those web services, etc., and how you integrate these services in web applications or in other applications. So this is an example how this body of knowledge is defining concepts, and then you use concepts to integrate it and to define the skills. Practically speaking, to develop the BOC, we are organized in 7 working groups. You see them at the left side. We create pieces of the body of knowledge, then we will integrate them. And one particular important aspect is that we also are currently integrating the taxonomy developed by ERSC. So the terms and the concept used by the private sector is integrated here as well. Currently, there are almost 1,300 concepts. You can reach them in a platform, and the description, I think in the meantime, because last week we released the first intermediate version, is even higher numbers now. Then this is used for many things, but I give just one example. It can be used for doing curriculum design, not only academic, can be also vocational training by anyone. So what we do, we have a tool developed to allow to structure your content, your training with an abstract. You borrow concepts from the BOC, you define particular, or you borrow them from the BOC learning outcomes. You can define pre and post requisites, for example, the order of things to do the training. You can refer and you can use certain training materials that are in the BOC, etc. And from there, you can, for different occupational profiles, for a manager is different than for a technical remote sensing expert, for example, you then define flexible learning paths. And we do that in a sense, it's quite innovative and new. We don't define just overall, some professors or other people have ideas. No, we start from real existing work processes that we model with BPMN, with a standard to do modeling of business processes. These are split, of course, in different tasks. Many actors might be involved, different profiles. You need to define from the task the concepts and the skills related to that. You group them in skill sets, and you might group them further in job profiles that you define then, and maybe you can create a job offer, and can be many different things. So skill sets are usually linked to a job profile. What is interesting, though, is that while doing this whole work, you can also assess the work processes as they are. For example, monitoring air quality is an example of a process. And there you will see that you might optimize the workflows themselves as well. So currently we have described 30 plus business processes, a lot related to smart cities, climate change and integrated applications, agriculture, etc. This is just an example of such a BPMN model on what is called flood mapping and flood risk mapping, where also Copernicus technology and services, the data come into focus. To support all this, we are developing a tool ecosystem that will be available for the whole community, for anyone. So the body of knowledge is kind of in the center of everything, because we needed to visualize, to explore what is in the book. We have a living textbook that allows to feed the book and to maintain it. But then we have several tools around it, like the CD tool, the curriculum design tool. We have other tools as well. For example, to define learning paths, still to be developed, but that's one of the ideas. We have already an occupational profile tool. We have a book matching tool, for example, that will allow you in the future to have an annotated CV of someone and try to match it and to check whether it fits with a job offer or a job description or a job profile that has been published by a private company or a public sector body, it doesn't matter, etc. So job offer tool is also another tool that will make use of the BOK and occupational profile tool to really describe and prepare the job offer and to put it online, etc. And in the future, we will also look into curricula vitae tools. So all these tools will help, in our opinion, to bridge education, supply and training demand in the sector. It's part of a wider vision because we link to others. For example, there is another vocabulary, ESCO, from the European Commission, that defines already a series of occupational profiles, and we will try to feed the ones that we define and the community defines, we will feed into the ESCO, for example. And we offer and we develop also APIs, and the tools is not just to be used for free in a platform, but also you will be able to build further on the BOK to make your own tools, to reshape the tools because they will be open source, they will be available for reuse. And let's say the ontology-based BOK is kind of motor of all of this. So currently in total, there are 6 tools ready and they are currently being tested within the EO4GEO consortium. And probably by September, we will have a call for contributions and for participating in the testing. I'm almost finished, but EO4GEO is also looking to the future. An important concept in EO4GEO is that we consist already in EO4GEO as a network of networks. DISIC, the general coordinator, is a network, in fact, is an association. We have also NEREUS on board, it's also a network, ERSC, a network, climate geek network, etc. But we also have a lot of networks as associated members from Agile, OGC, EuroSDR, Eurosol, other EITs, Agoria in Belgium, local networks, etc. So this is an important concept because we think and we have the aim to reach out and to mainstream what we develop. It's not just for our own use and for our own sake, but it should be embraced by many others. So therefore, the concept of network of networks. And then we are currently developing and preparing a sustainable strategy with a governance model, a business model, and a business plan. Also, mechanisms to maintain.
May I ask you to conclude more or less in 1 minute, please?
Yes, I'm just on my last slide here it's like a call for every one of you. You can contribute to EO4GEO and activities. You can contribute on the long-term action plan, the skills intelligence in one or another way. You can still also join or be candidate to become a member of the network of experts. We have currently 180 globally individuals. You can contribute to the testing of the tools that I showed, but you can also, as an organization, become associated member. Currently, there are 34 even, but more to come. And with that, I want to thank you. And if there are any questions, I'm happy to try to answer them. Thank you so much.
Thanks a lot. From my side, indeed, we see that there is one question. I would ask you, please, could you answer with typing answer later in the session?
Yes.
Because we now will give the floor directly to Roya Ayazi from NEREUS. Please, Roya, could you explain everything about NEREUS by yourself?
Hello, good morning. Thank you for the invitation. And I'm glad to hear. Do you understand me?
Yes, perfectly.
Okay. I'm glad here to present you some of our activities. I have been asked to shed some light into the Copernicus for Regions initiative, which might be quite relevant also for the stakeholder in Bulgaria. I prepared a little presentation. I have to see, share screen, yes, and explain you also a little bit the rationale behind it. Yes, okay. We are a regional network. Just briefly who we are, what we do, and what is our mission. Some of you know us, but for those ones, just briefly, Network for European Regions is the only, let's say, platform for regional stakeholder. Our objective is to spread the use and understanding of space technology in a regional context, bringing space users the added value of space information in the context of territorial policies, of regional policies, in the public sector. We, like the regions, are our members. We have currently 24. The Italian regions are the largest group, followed from French and Germans. We have 2 Polish regions, and we strive really to expand in areas which do not have long space traditions. What is really important is that you don't need a space industry or a space tradition to be a member in our initiative. It's about the use of space. And we address the stakeholder in the territories. The region and the administration is the member, but our activities address all the players of the innovation triangle, the universities, the research centers. And we work on 3 major columns: advocacy, political dialogue, interregional collaboration and partnerships, and new trends, public outreach, showing what can you do with space. And Copernicus for Region is a political dialogue because we develop in the frame of this initiative tools, material, particularly targeted to the policy level, to administration also, but to politicians, to members of European Parliament who decide about the future space budgets, to regional politicians who set the regional policies in their region, and to really show what is the societal value of the system. Copernicus for Region was, or is, an example for an interregional collaboration, and it contributed to build partnerships. I will explain that we have already a tradition and that different regions work together in this frame, identify common interests, and continue in other projects to work on these matters. In a nutshell, NEREUS is about extracting the or transforming the data into useful information for people, companies, and organizations to better understand this process, to support this process, and to create material that supports and enhances the process. Why are people look at me, and the problem is that regions are not entities that are all the same in the 27 member states. They differ. Let me just briefly explain why no matter where you are in the value chain, no matter what kind of stakeholder you are, why region are important when it comes to building the markets for Copernicus and to spreading the use. Why does this happen? Do you still see my slide? Yeah. We have 207. Yes?
It's okay, yeah.
Yeah, 276 regions in Europe. It's the level next to the national state. And now we are in a crucial, you have probably read a lot in the media. In Brussels, they are currently negotiating the next EU budget. Then the next EU spending for the next 7 years. And when you hear all those figures, you have to bear in mind that 55% of all public spending in Europe is done at local and regional level. When you look at the EU budget, at the large EU programs, a great part is implemented at local and regional level. The agriculture budget is one of the largest in the EU budget. The second column, which is quite considerable of the EU agriculture programs, is implemented at the local and regional level. Also, like when you look at the regional funds, the structural and regional fund, one of the largest bulks of EU spending is implemented at local and regional level. And when you look at EU legislation, not only environmental, but environmental in particular, 70% of this legislation is implemented at regional and local level. So they are your interlocutors. What was one thing why we work on Copernicus for region is that we monitor the situation. We monitor the situation amongst our partners and members, but even more, we want to know what is the situation broader across Europe. How do regions use Copernicus? Do they use Copernicus? How many use Copernicus? And what are their problems? And in many workshops, interactions, consultations, we learned that although Copernicus entered the stage of operability, we are far. Sentinel data is free and open available. You have a lot of tutorials. The Commission did a large framework contract on user uptake. Still, use and understanding in Europe is very diverse. You have very different levels of maturity when it comes to using Copernicus data. You have, again, and that is not fair because all European citizens pay into the system, pay with their taxes, and they should be also able to use and benefit from Copernicus in the same way. But you see in regions that are highly industrialized, that are highly specialized, also the factors to use and the administrations have often a higher maturity. And we need to do more to have a more equal approach. Our understanding is that Copernicus is a common good. Copernicus is a common infrastructure for all Europeans. And we need to make sure that at least a crucial part of regions is aware of the possibilities and can get access. One important thing what we are working on and in our discussion is to better understand what are the factors in regional administrations that contribute to open doors, that contributes regional decision maker to decide we deploy Copernicus, we look into what can Copernicus do for us, what is in there. Because in the end, Copernicus contributes to improving public services, to improving, revolutionizing, modernizing public administration. And in the end, that helps us to have more satisfied citizens. That is our argumentation when we go and talk to politicians. And we see in all the regions we work with, the political will is key. That is often the starting point, that the political level has an understanding, that the political level gives a mandate, that the political level opens the door. But it's not enough. In regions where the political level is convinced, but they don't manage to involve, they don't manage to win, they don't convince the technical level, it doesn't work. So we need to do the awareness raising, the understanding of the benefits and the education training on the different levels of a public administration, of the policy level, of the higher administrative level, and on the level of the people who are concretely working with it. And it's a very long and difficult process, but we need to do it because in the end, the largest group are local and regional authorities, and once you get them to use, you manage, and it's a normal process, and we saw it. They start defining their needs. They start giving feedback on their needs. They start telling you, is that useful or not? What we need, what we are looking into is also Copernicus data is free and open accessible. However, for a concrete local or regional administration, a fire department for responsible for forest fire, or environmental department, they cannot one-to-one use the satellite imagery. They often need a software, they need additional service to really use it. And there is where you have really problems in public administrations, especially now when you have the political will, everybody focused on recovery from COVID. Then you really need smart financing modules, and you need really good arguments, how much better you deploy resources, how much better you are able to save money with the use of Copernicus. We work very much, and this work is not completed yet. There we need really the support of researcher, of service provider, better matching regional competences with available services, explaining in the context of regional competences, regional policies, regional services, what can Copernicus do? We have a number of strategic partners, and the European Space Agency is one of our longest, and we built a partnership with ESA ESRIN to promote the European Earth observation system at regional level, and to make like a snapshot, what is the situation, what are the needs, what are the difficulties. We started in 2012 with the first publication, calling across Europe, inviting everybody to provide us with a user story, how regions use Copernicus. It was at the time very difficult. We promoted for, I think, 9 months through different channels. We managed to get 67 use cases. At the time, a lot of them were not very mature. The majority of these cases were model projects. We then continued and sat and looked and assessed the material, and said we need to know more about the processes in administration, and organized then with public administration a series of workshops where we showed what can you do with Copernicus. We showed examples from the booklet, but also other examples, and asked the local and regional authorities to give us a portrait, to give us some elements of what they are concretely working on in their field, in their maritime department, in their forest department, and to show them what we can do and what are their problems. These were very, very intensive talks, and we drew some lessons from it and analyzed them. and brought the findings in a final event to European policymakers and discussed them and gave input to future Copernicus programs and policies. Some years passed, Copernicus got more operational, and in 2017 we asked ourselves, well, we would like to know from 2012 when we produced the first publication, what is the situation now? Has the number of Copernicus users grown? Who are the users? What is their situation? What is their level of maturity? And in what areas do they use Copernicus? And we defined together with ESA and the European Commission a call, which we promoted very broadly across Europe. And we received more than 100 responses, of which we selected 99. We grouped them around 8 areas with high relevance for regions, namely agriculture, food, forestry, fishery, biodiversity and environmental protection, climate, water, energy, territorial management, urban planning, civil protection, transport, public health, cultural heritage. And the response was really, really positive. We received responses by a total of 177 entities that were large author teams that responded, and we could realize our objective to have a strong focus on local and regional authorities. We managed to identify public users, and we quoted them also in every story you will find in the booklet. We were very pleased to see, we analyzed the stories we got, and we looked at them. We made a matrix of 5 maturity level, like explorer, ad hoc user, pilot, experimental tester, early adopter, or operational user. And we gave each story as an assessment of which maturity level it is. And we could see that compared to the first publication we produced in 2012, there was a considerable evaluation. As we are an advocacy organization, it was for us very important to use this material not only for the Copernicus community, in inverted commas. It was very important to us to develop material specifically targeted to the political level and specifically targeted to the administrative level, senior level, but also the operational one. So they can really learn from other regions. They can partner with other regions. They can really see concretely in regional competences context, what are others doing? And I'm not really good with this system. I like to show you our website where you can find the material. I make stop sharing and I hope it will work. I go to our, yeah. Can you see? No, you can't. 1 second. Share screen. Yeah. You can, like we have on our website, here's NEREUS projects, and you get a special button for the Copernicus for Regions initiative. You can download the publication, and we produced 5 videos, very short, 3 minutes from 5 different regions. And also in the native, like you have subtitles in the native language of the regions with concrete examples. Navarra, how the region of Navarra uses Sentinel imagery to be better prepared for forest fire. How Nouvelle-Aquitaine, a coastal region at the Atlantic, uses Copernicus satellite imagery for coastal management. How Wallonia, a former brown coal mining region, uses satellite imagery for brownfield monitoring. how Milan, an Italian region, uses satellite imagery for better monitoring the water infrastructure. Since we work with administration, it was important to bring some of the materials, some of the stories and the initiative in native languages of, it was for us of the most spoken languages in the Union. So you can go, we have a search engine and you can look for either specific thematic areas, you can look for a specific region of application. So you want to know from your domain, you can look for languages, you can look for specific thematics or maturity level and extract the story that is for your interest. We have also information material in different languages on the initiative. So we have flyers, and so you can have an insight on Copernicus for Regions, because Copernicus for Regions is not only a project, it's about community building, it's about understanding, it's a big archive of Copernicus users. And I go back to my presentation, and we are very much to the end. So here I am. Can you see my screen?
Yes, yes, I see it.
It's like the one new collection and 5 user stories and yes, the 3 boxes on the right. Okay, perfect. Then I'm very much at the end. We are now working on looking into if we find updates, if we can grow the collection, and working on extracting really concrete topical selections. So if you have specific interests, you can more easily find it. With this, I would like to thank you for your attention, and I'm here for your questions.
Thanks a lot, Roya. So I just checked. Still, there are no questions, but you should know that your publication, the publication you mentioned, has been already distributed through our social channels, through the colleagues. At the time it was issued, so most of the people here in Bulgaria, they know about it. Definitely. Anyway, if there are some questions during the presentation, please check the Q&A section and please reply. If there are some later questions which we will put later, we will send it to you. Thanks again. Thank you very much, Roya. And now I would like to give the floor to Monja, Šebela. Sorry for the pronunciation. Now we are going to big things, big Earth observation data. Next 3 presentations will be related with this topic. Monja Šebela from Sentinel Hub, please, the floor is yours.
Hello, can you hear me well?
Yes, very well. Good.
So I come from Sinergise. This is the company for geoinformatic geographic systems stationed in Slovenia. What we do is we take the satellite data that is provided by Copernicus, by NASA, and by other providers, and we make it easier for the users to access them, to process them. We kind of hide the complexity behind it. We give them the user interface that they can work with. And one of the biggest things that we provide with Sentinel Hub is the API, which the users can use to get the satellite data into their own applications and then sell them commercially. But today I would like to focus more on what we do for the community, on the free source codes that we have, the programs that are free to use for anyone, and the custom script contests that we are organizing to raise the awareness about the remote sensing data, and of course to bring people to realize how easy it is actually to do analysis with it, and maybe, you know, change the world with this. I will now share my screen. So yeah. So the first thing that I would like to show you is actually in real life, how you can access data in EO browser, the completely free application. Can you see this well?
Yes.
Okay. So this is EO browser. You can find it by just Googling EO browser.
Sorry, in fact, we see only your presentation.
Oh.
Not the browser itself.
Okay.
You could share the screen, the first option when you when you click on share screen, choose the first option, screen, not the not presentation.
Yeah, I can see it. Okay. Better?
Yes.
Okay. So this is the first page of your browser when you can see the different data sets. And for example, if we choose Sentinel-2, we can then specify L1C or L2A. And Sentinel Hub also calculates the probabilities of cloud. So we can here select how much cloud coverage we want, and also the time range, and then click search. And then we immediately, when this loads, get the tiles that are available for this time span and the approximate area where we were. And when we visualize it, we actually get a mosaic of all the different tiles through the complete, the swath all over as the satellite passed. Then here we have already prepared a lot of a couple of visualizations with descriptions, such as the moisture index, that the user can just click and observe. But what is maybe the most powerful tool of EO browser is the custom scripting option. So here the users can very easily just create composites and even indices. And then if they want something more complex, they can write custom scripts in JavaScript code here. Now these custom scripts are very powerful. They have support also for data fusion, multi-temporal scripting, whatever you would need. Now the interesting thing also for the free source data is that you can download any image by just going here, and then you can download any kind of format that you want, for example, 32-bit float. You can check any of the visualizations you want, any of the bands, and this will download for you. And this will download the whole mosaic that you can see on the screen here. So this is very useful for the users because it simplifies the process of going to the Copernicus hub and downloading each tile by themselves. Now, EO browser also has a lot of cool features that I will now show you right now. But just to give you a taste, you can create time lapses, you can create pins of interesting locations and share them. We have education teams, 12 teams with a lot of locations already selected as highlights that you can explore. Statistical information, calculating, comparing the locations and stuff like that. And this is all completely free source. You can find the source code on our Sentinel Hub GitHub, where you will see a lot of repositories that you can explore. And one of them is EO browser. So you can just, any user can take a look at this code, make a similar application, and they have all the rights to use it. One of the most interesting repositories are custom scripts. Custom script repository, which this is just a prettier GitHub page, but it's also accessible on GitHub. anyone can contribute to this, and I would actually encourage all of you who are interested in remote sensing to contribute your own scripts. It's actually it's very interesting and fun to do so. So these scripts are classified by data sets and by teams, and you can see we have a lot of them here already, including the newly added data fusion collection down here. So each of the scripts has a description, an image of how it would look like, an author, and then you can easily access it by just clicking on EU browser, and it will just throw you into EU browser, upload the script for you, and it will instantly work. You can then, of course, download this data, modify it in a custom script, whichever you want. You can also view the script here and copy and paste it. We are very excited about this. We are adding the scripts constantly, and this is a way that the users around the world can simply, develop and create new solutions to real-life problems that anyone can then use very quickly. Connected to these custom scripts, we are preparing custom script contest. Now 3 of them are already completed. In these contests, we want the users to compete with the best custom script, and we grade them by originality, scientific relevance, global applicability, commercial potential, and visual appeal. Now I'm going to just show you a little bit of what our users have posted. Of course, there are also prizes associated with that, and all the scripts that the users post go to the repository and they're free to use for anyone. In the first contest, we had 11 participants with 17 scripts, and the one that won was the Deep Moist Convection by Stavros Defis, where the deep moist convection areas are highly correlated to tornadoes, to hail and other unpleasant events like that. And with detecting them, we can help prepare for such events. Then another one, now I am just showing you a couple of chosen ones. I cannot show you all of them because there's a lot of them. This one shows the water turbulences. It's useful for detecting of waves and for white water on larger rivers. Then this script, the monthly snow report, takes a look at the snow cover in the last month or the chosen month, and then gives you actually it's very good for snow detection and to see how much snow have accumulated. This one is also interesting. Someone, Mohor Gardner from Slovenia, calculated land surface temperature from Landsat 8 and also from other satellites. He created a script that you can, of course, take a look at the repository. And then we had a custom script contest number 2. So the first one had a lot of themes that the users then had to categorize by, like agriculture, urban, water, and stuff like that. But here we decided no more categories because it is sometimes difficult to categorize scripts by categories. And then some scripts were in multiple of them. So here we got a bit more of the applicants, and altogether got 23 scripts, quite a lot of them made with Sentinel-1. Here we really wanted to also attract high schoolers. We created a tutorial for beginners so that anyone could start scripting without even the basic remote sensing knowledge. And we were writing to schools, but unfortunately, none of the scripts were made by high schoolers. So the winning script here was the Ulysses Water Quality Viewer, which takes a look at the sediment content and the chlorophyll content, which are both contraindicative to the good quality of the water. SAR ice, sea ice RGB composite is useful for detecting ice and taking a look at the ice depth, type, and water windiness. It's created with Sentinel-1. This one is a little bit aesthetic script, tone map natural color, which is especially beautiful on very bright areas such as snow and clouds, as you can see here. We already use a little bit different version of this one and of the water quality viewer in EO browser. This one is SAR vegetation index, where the Walters created a script based on the vegetation index calculated in SAR in a multi-temporal script, and these are the pretty cool results that you get. The most recent finished custom script contest was a COVID-19 themed, where the users were given access to Aero Data Cube functionalities as well, and also to commercial data sets. Planet, for example, was very kind to provide some free data sets, data for the users to do. So what we wanted here is specifically to make an impact, to create an ideas and scripts that would be useful in battling COVID-19 in a way of, preventing agricultural catastrophes, of monitoring, and of just seeing the impacts of it. So here we had 3 categories: economic operators activity, human activity, distribution, and agriculture activity. It was running for 13 weeks, and each week we had a weekly winner. The overall winner here was Hendrik Fischer from Germany, who detected trucks with Sentinel-2. And another 2 that I'm just going to mention quickly are this one on the left is actually takes a look at the impact of COVID-19 to the lettuce production. So the user classified the lettuce fields first and then took a look at the impact. And here on the right, we can see the script, which takes a look at the water quality before and after, actually before and during the COVID. And as you can see on the image above, the water was a lot less clean than on the image below. Now, right now, the custom script contest is running, which is also going to incorporate EO-Learn. It has just started, it is in progress, so anyone can compete. So what is EO-Learn? EO-Learn is a Python library or a set of Python packages that aim to bridge the differences between that aim to bring together remote sensing and Python by providing the users with the tools to easily create the workflows to do machine learning processing, statistical analysis, and stuff like that. So EO-Learn actually, EO-Learn, just a second. EO-Learn has a wonderful documentation created. I'm sorry, just let me open it up. Yeah. Where you can read about the installation, about what it covers, and there are also very good examples here. So basically, EO-Learn is created, consists of EO patches, which are like the little areas of that you fill with data. EO tasks that you have already defined, quite a lot of them that you can simply use, and also you can create any task yourself with Python. And then of EO workflow, which brings the workflow together and specifies how the workflow is going to be done. So, for example, if we take a look at the example of land use and land cover, we would first define the area and then the EO patches. Then we would visualize these EO patches. We would every time first define the EO tasks and then define the workflow of how it is going to go. Then we would upload the reference map, which is ground truth, and then use machine learning part of EO-Learn to train the model, and to then at the end compare the results, evaluate them with statistical information, and just for example, here you can see the differences between ground truth and prediction and how it looks like in true color. So this is also free source, anyone can contribute to it, and we are actually be very we would be grateful if for anyone who contributes the source code, so that these repositories get better and better and are of more and more use to the general public, ministries, companies, and so on. One of the very interesting things that I wanted to show you is also the Blue Dot Observatory that was built with machine learning. And what it does, it takes a look at the water bodies around the world, like thousands and thousands of them, and then calculates the water area and monitors this for time, which you can just take a look at any date. And this is very useful. It was useful especially in South Africa, where they were monitoring this for the droughts and to see how fast these water bodies are diminishing. Okay, so yeah, I think this is it. I would just encourage anyone to take a look at our repositories and what you can do with it. Oh, I forgot another little thing. If you are not familiar with custom scripts and would like to start, of course, this is JavaScript. Not everyone is familiar with how to do it. You would just go to our website, sentinelhub.com, under Develop and Custom Scripts, where we have all the information you would need. We have created the basic tutorial that consists of a YouTube video and a PDF tutorial that is suitable for anyone, even for the people who have no remote sensing knowledge, because it goes from the beginning and tries to explain all the concepts. And then it would teach you the basics of how to create an index, how to do the basic visualization with, for example, if statements and so on. And then if you would want more complex custom scripts, you would go onto our documentation, where we have the custom script version 3 documentation, which is pretty lengthy and also has lots of examples. And then you will be also able to implement data fusion, multitemporal scripting, and so on. So anyone can start. This is also why we wanted high schoolers to join. Yeah, we would really like the community to see how easy it is nowadays. Also thanks to the Copernicus project, to work with the remote sensing satellite data, process it, download it, and so on. So yeah, thank you for your attention. Any questions?
Thanks a lot, Monja. So for now, I don't see questions, but let me assure you that we especially invited developers to our webinar, and they're aware of your presentation and the possibilities you're offering with these open source codes, etc., through Python and JavaScript. So definitely we could expect, I hope, more participants from Bulgaria in the next custom scripts. And thanks a lot for all the good work you're doing in Sentinel Hub. Thanks a lot. We will inform you if there are more questions. Thanks a lot.
Thank you.
So now we could switch to Jennifer Adams from ESA Phi-Lab to tell us more about how do they use artificial intelligence in processing data from Copernicus. Jennifer?
Hi, good morning, everyone, and thank you so much for inviting me to be here. Can you hear me okay, and can you see my screen?
It's perfect. We hear perfectly okay. Thanks.
Great. Yeah, so I'm actually a postdoc at the ESA Phi-Lab, and the Phi-Lab was a new lab set up about 2.5 years ago. And today I'm going to talk a little bit about why it was set up, what we do, particularly in relation to artificial intelligence, and then also show you some of the research use cases that we're working on. So for anyone that has attended this morning's session, I guess you've probably seen this slide already. So within ESA, we had a lot of traditional missions developed, whether they're science or Earth explorer missions, the Copernicus fleet, or also meteorology missions. These missions generally are dominated by sort of expensive rocket launches, rather long development times, and rather a lot of money to develop them. And as a result, only a handful of rich nations or space agencies are able to develop such missions. But in the recent years, we've seen what we call the rise of new space, or in Europe, this is called Space 4.0. And in the last 11 years before 2018, so from 2007 to 2018, we saw around 220 Earth observation satellites launched. But since 2018 and up until 2020, we're looking at seeing 562 Earth observation satellites to be launched. And this is where we're seeing a kind of a paradigm shift. And the reason for this is the falling costs of launching satellites into space is bringing along entirely new operators. So we're looking at reducing costs in not only the launch, but in also abilities of miniaturization of satellites, in agile development, network effects, in the cost of data storage, in the availability of free data provided, for example, by Copernicus, in data processing costs, in the costs of components, and in particular, the use of AI or machine learning in analysis costs. And so because of this change or paradigm shift, we're starting to enter a new era in space where we have the traditional Earth observation satellites from Copernicus, from our Earth explorers, from the meteorology missions, and as well as national missions. And these missions provide operational, reliable, and quality control data, which generally are free and open, and have a long-term perspective. But then we also look at Space 4.0. So this is new space players such as ICEYE, EarthEye, Planet, and other launches that look at cheaper, smaller, and commercial Earth observation missions, typically in larger numbers with higher revisit times and less focus on precision. And together, these two types of methods are complementary in many aspects. And so here at the Phi-Lab, what we're really interested in this kind of interconnected web of sensors. So what we're looking at is looking at a true integration of space using this global web of interconnected smart sensors, which basically is going to reshape the way that we use Earth observation data, as well as the services and applications that are managed and beneficial to society. So not only do we have this huge amount of new data, but we also have a lot of new technologies and approaches. So we have new investors, we have reusable launches, which we've seen particularly quite recently with SpaceX. We have lots of new computing capabilities. So the presentations that we've seen today, some of the new tools and ways that we can access the cloud and access the data. We also have a lot of new analysis techniques, such as artificial intelligence and machine learning. As mentioned, we have this huge amount of new data from this interconnected web of sensors. And we also have new technologies such as blockchain. And together we're looking at a new generation of satellites, which we call connected swarm, which are fully programmable and also AI powered. And so due to all of these new approaches, technologies, and also data, the Phi-Lab was set up about 2.5 to 3 years ago. So it's within the Directorate of the Earth Observation Programme, or EOP, and we are within the unit called Future Systems, which is a newly added feature to the structure of the director. And this new structure basically looks at reflecting the life cycle of the mission. So starting from the conception, so from the future systems, all the way through to the development or the projects, the mission management and the ground segment, and finally the science applications and climate or data exploitation. So at Phi-Lab, what's our mission? Well, it's to accelerate the adoption of disruptive technologies to extend Europe's leadership in Earth observation. And the aim is to create the right ecosystem for space startups to grow, to promote Europe's leadership in space, and also increase its share in the world space market. And our new strategy is to encourage the commercial use of space data by both public and private users. So within Phi-Lab, we have two main offices. One is, which you can see on the right-hand side of the screen here, is InCube. So this is supporting EO industrial innovation. And this is new methods of providing funding to Europe's private space sector. And the second office, which is the one that I come from, it's the Explore office, and this is looking at building capabilities for both traditional and new space. And in particular, we're focused on artificial intelligence. So within the Explore office, what we want to look at are the various transformative technologies that in combination with Earth observation could provide sort of new tools in our toolboxes. So this is looking at immersive experiences. So this will be virtual reality and augmented reality, blockchain, as already mentioned, the possibilities of using quantum computing, edge computing, AI-driven development, autonomous things such as autonomous driving, and also augmented analysis. But what's particularly of interest to the lab is actually AI. So this is what we call AI for EO. And within this, we have various different parts of Earth, artificial intelligence for Earth observation. So what we look at is decision intelligence, forecasting and prediction, which is particularly important, for example, in data assimilation or climate modeling, anomaly detection, feature detection. So this is looking at detection of hazards or cars, roads, features, buildings. We look at multidimensional data. So what's particularly of interest to us is hyperspectral data, which is becoming particularly important and at the moment. We also look at autonomous systems and also workflow optimization. And what we're working on the lab is developing this kind of a processing chain or an AI for EO data engine. So we're trying to look at a full processing chain here, where we start with the data preparation. And as any of you who've worked with Earth observation data know, that this is a huge part of what you need to do for applying any kind of algorithm. We then work on model training and testing, so often on GPU, and we focus specifically on open source software. We are then looking at developing a kind of app store, where we look at the different applications of artificial intelligence for Earth observation. And then we look at deployment, and that can be either inference or AI at the edge. And I'm going to now introduce a few of the different case studies that we're looking at, which is related to this kind of processing chain or this data engine. So one of the first case studies that we work on is crop classification for with transfer learning. So this is in partnership with UNICEF, WFP, which is the World Food Programme, and Stanford University. And this is basically where drone data has been collected in a few different countries in Africa. So I think Malawi and Mozambique and one other. So this drone data is then used as training data at high resolution for crop classification. A convolutional neural network was pre-trained on some of the classic convolutional neural networks, which are generally trained, for example, on cats and dogs. We then add some more data, we retrain on Sentinel-2, and then we create training data for crop classification, which can then be used in our Sen2 Agri software. A second example that we're looking at is deep learning cloud computing with open data for desert road mapping. So actually here, the training data was generated using a crowdsourcing software that was developed in the lab, and I'm going to introduce a little bit later. And this used basically the crowd to detect desert roads. And using Sentinel-1 data, a UNet was applied, and basically desert roads were able to be mapped. I'm not entirely sure which country this was in, but yeah, so we used the classic UNet network to map desert roads. Another project that we're working on is methane retrieval from Sentinel-5P. So Sentinel-5P is one of Copernicus' satellites that's aiming specifically at greenhouse gases. Currently, the techniques are based on what we call optimal estimation methods, which tend to be quite slow. And when you want to look at an operational or near real-time retrieval of methane, which can be quite important, and especially it's something that we've seen during COVID, that being able to map air quality in near real time is quite important. So the aim here is to train a network to learn the physics of some of the processing chain, which include a particular physical model that looks at greenhouse gases. And what we look at is instead of the full run of the original algorithm, which takes about 10 seconds, a neural network can perform exactly the same analysis much faster, so up to 10,000 times faster. Another case study that we look at is wildfire mapping in New South Wales. So this is based on the huge bushfires that happened in Australia last year. Sentinel-1 data cube was developed using an in-house tool called the OpenSAR toolkit. So images were generated every 12 days at 10-meter resolution, and currently our work is undergoing developing an AI algorithm to try to detect burn area and active fire hotspots using this kind of data. Seeing through the clouds competition is done in conjunction with the Advanced Concepts team, which is a team in ESA ESTech, and it basically looks at reconstructing Sentinel-2 images behind clouds based on time series of Sentinel-1 and Sentinel-2 images. So as most of you know, using Sentinel-2 is a great mission, but being optical, it means that we sometimes can't see always the surface. So we're basically using Sentinel-1 to try to understand what's behind the clouds. And this can help us develop kind of more time series analysis. And based on this, we also have some similar approaches, but based on data fusion. So we're looking at fusing Sentinel-1 and Sentinel data using the FuseNet convolutional neural network. And finally, we're also looking at exploring a kind of new data-driven science from the SWARM mission to see whether or not magnetic signals can be correlated with earthquakes. And this is based on deep learning, so yeah, an RCNN, and it's trained particularly on GPU. So finally, I want to go a little bit into the tools that we're developing. So as you can see in the image on the left-hand side here, most of data scientists, I think, spend about 80% of the time cleaning and organizing data and collecting data sets. But it's also the most unenjoyable part of data science. So what we're trying to do at the lab is to try to make this easier for people. So one of these toolkits is the OpenSAR toolkit, which basically looks at creating ARD data for Sentinel-1 SAR mission. And what we can do is create analysis-ready data for different combinations of the Sentinel-1 bands. And it also allows us to do time series processing and also multi-temporal statistics. And you can also do this at large-scale mosaics. And we also have a tool called Iris. So this is intelligence for image segmentation. And this allows users to basically segment images, so to detect clouds or landslides or any kind of hazard that they're looking at, or burned area. So the burned area work that I mentioned before has also been using this tool, and you can basically create training data in a really easy way for your AI algorithms. And then we also have a crowdsourcing platform, which is called PyBossa, isa.pybossa.com. It's currently being used for detecting buried archaeology. It's still ongoing, but the paper, as far as I know, has been almost published. And finally, I want to talk a little bit about AI at the edge, because this is something that we're particularly focused on within the Phi-Lab. So the trend of miniaturization is something that we all know quite well, and the iPhone 6 has the same amount of processing power as the IBM Deep Blue in 1997. But now we're moving beyond this, and we're actually looking at edge computing, which are optimized specifically for artificial intelligence. And this will allow us to move to what we call the ultimate edge, which is space. And within the Phi-Lab, we have the PhiSat experiment. So we know that convolutional neural networks have disrupted the field of computer vision. And the question is, can they be deployed to spacecrafts, and what new technologies would be needed to enable this? So the PhiSat experiment works with a hyperspectral sensor from Cosine, which is in the V-near and the TIR, looking at a spatial resolution of about 75 meters. We have hybrid computing, so this is where we have a visual processing unit called the Movidius board, and this is optimized specifically for convolutional neural networks. We pre-train an algorithm, and we basically do this on the edge. The experiment that we focused on is cloud detection, because for hyperspectral remote sensing, due to the large amounts of data, being able to not send down all of the data, for example, in very cloudy areas, is very, very useful. And here is a demo of the algorithm that was developed. So you can see this is what would happen in near real time, that we have a tile. And the algorithm would decide whether or not to download or not download the image based on the amount of cloud in the data. So as you can see in the next tile, that this one would have been rejected. So just to wrap up, at the Phi-Lab, we also have a host of visiting AI professors from Europe, and they help define the strategy of AI and Earth observation, as well as Copernicus for ESA, and also supervise some of the research work that's happening in the lab. Within the lab, we're also the secretariat of the world's first artificial intelligence special interest group in space, which is jointly between ESA and CLARE AI. And CLARE AI is the Confederation of Laboratories for Artificial Intelligence Research in Europe. For more information, you can go and visit the website there. And finally, for anyone that wants to come and work with us, we have different methods. So we have visiting scholarships, we have industrial fellowships, for example, with Airbus, we have InCube's co-funding, and also funding from Science for Society. So with that, I'd like to thank you for your attention, and for any information, you can visit the ESA website. We also have a blog, we have a GitHub, which has all of the tools and the research that I've mentioned already here today. And just a couple of weeks ago, actually, we had a brochure that has been released online that tells you in great detail all of the research and innovation that we do within the Phi-Lab, whether or not that's the research, the tools that we develop, the outreach that we do. And so, yeah, thank you very much.
Thanks a lot, Jennifer, for your very, very informative presentation, and thanks a lot also sharing with us in your last slides the opportunities which different types of organizations could collaborate with ESA Phi-Lab.
Welcome.
There is one question about how much do you use AutoML in processing of the data. Could you please answer later on?
Yeah, sure.
Answering, because we have to move ahead. Thanks really a lot. It was a really interesting presentation. Thanks. So now it's turn to Mr. Alexiev to show us what the scientists in the Institute for Information and Communication Technologies at the Bulgarian Academy of Science are doing. Mr. Alexiev, if you could speak in Bulgarian or in English, I think it's your choice. Most of the presenters are from Bulgaria, but there are some attendees from abroad. I see that your presentation is in English. Whatever you like. Please.
Can you hear me? Can
yes.
You hear me?
Yes.
Yeah. Do you see my presentation?
Yes.
Okay. I will make presentation in two parts. The first one, introduction in English, and the second one in Bulgarian, because I have very little time. I see we are late 15 minutes.
Yes, more or less 15 minutes in order to have 5 minutes between this one and the next session, please. Thanks.
Hello to all 61 participants in our session. COVID-19 forces us to hold the meeting in a special way, talking not to each other, but on our own computers. In spite of this, I think that all of us will have benefit from this unusual meeting. My presentation is dedicated to the processing of data from satellite observations. You already know that Sentinel satellites generate a huge amount of data. Although we have obtained data in several different levels of preprocessing, level 0, level 1, level 2, level 3, we often need to do something more, to process something more this data in different applications. The team managing and disseminating data from European satellites give success to some available computer resources and also to some tools. Monja and Jennifer make very good explanation of these resources in previous presentation. This presentation is intended for those who wish to process further satellite data on hardware which is capable here in Bulgaria. And we will do all the best for this large amount of data. The content of my presentation is in 3 parts: available hardware tools, available knowledge in methods and algorithms, and area of application. And now I will make smooth transition in Bulgarian language. Естествено ще започна първо с описанието на българския суперкомпютър, защото той е най-голям не само в България, но и на Балканския полуостров. Това е така наречения Авитохол. Вие виждате картинки от Авитохол. Авитохол работи с Red Hat Enterprise for High Performance Computing операционна система. Той е снабден също така с Intel Cluster Studio Compilers, които поддържат Message Passing Interface. Също така пълна GNU Compiler Collection, която е freeware, вие знаете това. Освен това, в софтуера към компютъра има също така има също така различни приложения за мониториране и отчет на потребителите, за създаване на виртуални машини и най-различни библиотеки от типа на Boost, MUMS, Octave, OpenFOAM, VRF, NetCDF, Gromax. Някои от тях естествено са с общо предназначение, други са за решаване на редки системи от уравнения. Octave е свободно разпространяваната версия на MATLAB, но други от тях могат да свършат много добра работа и при обработка на сателитни изображения от типа на VRF, което се използва за анализ на климата. Какви са техническите данни на този компютър? Той се състои от 150 нода, които са от 2 CPU-та, от 2 Computer Processing Unity от генерация 8. Всеки от тях има 8 кора и 16 хипертреда. Достъпната памет е 64 гигабайта за всеки възел. Освен това, суперкомпютър разполага с 300 Intel Xeon Phi копроцесора, всеки от които разполага с 61 възела кора с 244 хипертреда. Тоест, общото количество на наличните в суперкомпютъра възли са малко над 20 000 или 2400 плюс 18 300, ако ги съберем възлите в основните изчислителни устройства и копроцесорите. Тоталната памет е 14 терабайта. Към суперкомпютъра е установена и дискова памет в обем на 100 терабайта. Връзката между отделните възли се осъществява с неблокираща InfiniBand. И латентността, забавянето е по-малко от 1,1 микросекунди. Обмена на данни е от порядъка на 56 гигабит за секунда. Вие знаете, че най-добрите персонални версии трудно надскачат 3-4 гигабита за секунда. Изследванията, които направиха колегите, които се занимават с суперкомпютри в Института по информационни и комуникационни технологии, който стопонисва този суперкомпютър, показаха, че CPU-тата имат върхова мощност от порядъка на 50 терафлопа или сумирано заедно с копроцесорите, сумарната мощност на суперкомпютъра от порядъка на 412 терафлопа. До сега направените измервания показват, че може да се достигне 264 терафлопа за секунда. В момента, в който беше пуснат в действие този компютър, беше на 389-то място в света. Тази класация обаче се мини много бързо. Това са данни от ноември 2015 година. За 5-6 месеца този компютър изпадна от топ 500 компютъра листата. Мощността, която изразходва този компютър, е около 50 кВт и процесорните елементи се охлаждат с вода. На снимката вдясно виждате кулъра, охладителя на течното охлаждане на суперкомпютъра. Тук виждате Xeon-Phi копроцесор, какво представлява като хардуер и неговите данни. Няма да ги споменавам подробности. А това е конфигурацията на един възел, 2 CPU-та, 64 ГБ обща памет и 2 копроцесора. Колегите са направили различни изследвания върху производителността на компютъра за различни типове алгоритми, използвайки OpenMP. Това е Open Multiprocessing на ниско ниво разпаралелване и можете да видите какви са данните за бързодействието на този компютър. Така и общите тестове също можете да ги видите тук. Към този компютър бяха закупени допълнително и 36 Blade сервера Xeon X5560, като към тях има 16 NVIDIA Tesla графични карти. Преди малко колежката Дженифър говореше за Artificial Intelligence. Точно тези NVIDIA Tesla карти са приспособени много лесно да бъдат запрограмирани за нуждите на задачките на изкуствения интелект. И, така. Сред многото задачи, които се смятат до този момент на суперкомпютъра, намерих една задача на един познат научен работник, доцент Пенева от Софийския университет, която изследва спътникови изображения за построяване на физически модел на Черно море. и привеждам картинки от нейната презентация. Така, какво включва портфолиото? Този суперкомпютър може да се ползва от всички научни работници, включително и с софтуер, който те могат да си качат на базата на open source софтуер, достъпен и по линия на програмата Copernicus и наличния до този момент и качен на суперкомпютъра софтуер. По принцип, нашата институция има упълномощени хора, които оказват пълно съдействие на хората, които започват работа на суперкомпютъра. Вие виждате вдясно част от лекциите, които се провеждат в обученията за използване на суперкомпютъра. Като обучението включва както Message Passing интерфейса, Open Multiprocessing, CUDA програмиране и всички други необходими познания, които са нужни, за да можете да си качите задачите и да ги пуснете на суперкомпютъра. В момента, за изминалите години, от тогава има и значително количество апгрейди. Почти всичките наши проекти са свързани с развитие на суперкомпютърната техника. И тук виждате няколко от новите устройства, които са закупени от тогава до сега. Авитохола е уникална система и може би най-мощната в региона, която предоставя значително по-голяма мощ от предоставените устройства в облачните виртуални пространства, с които може да се работи, стартирайки различни приложения към програмата Copernicus. Ето защо за всеки един от вас, който има сериозно приложение, му пожелавам да използва този суперкомпютър. Втората част от моето изложение включва достъпната експертиза, която притежава Института по информационни и комуникационни технологии, която може да бъде използвана в областта на обработка на сателитни данни. Тук са приведени най-популярните примери в областта на фюжън технологиите, в областта на моделирането, в областта на Artificial Intelligence, паралелното програмиране и Security. Фюжън технологиите за първи път се споменават в началото на 90-те години на миналия век, 1991-1992 година, в един доклад на членовете на Joint Directors of Laboratories се установява базовата терминология, която по-късно се използва като научна терминология в областта. Независимо от това, за фюжън се говори значително по-рано, без да се нарича естествено фюжън. Например, спускаемия апарат на НАСА на Луната не би могъл да действа, ако не бяха обединени данните от множество сензори и обработени съвместно, за да може да се установи точно позиционирането на орбиталната станция, на спускаемия апарат и успешното връщане обратно на спускаемия апарат на орбиталната станция. От тези хора, които за първи път споменават тази думичка фюжън, с трима от тях поддържаме добри отношения, като един от тях, Алан Стайнберг, това е крайния вдясно, даже е бил в България и изнасял лекция сред нас. Има 4 нива с нулевото ниво 5. Ще съкратя презентацията. В обединяване на информацията от множество сензори или от един и същи сензор, но в различни моменти от време. Няма да се спирам върху това. С помощта на Fusion апарата може да бъдат откривани цели, да бъдат идентифицирани, да бъде оценявана ситуация, опасности и да бъдат управлявани измервателните уреди и оптимизирани по начина, по който да бъде използвана тяхната информация. Моделирането ни помага на базата на най-различни източници от физически модели, функционални модели, поведенчески модели, с реални сензорни данни, с текстова информация във вид на база данни и с информация за политика, доктрина или гайдлайнс, да получиме потребителска ново качество на информация за потребителя. Така. За Artificial Intelligence ще го пропусна въобще. Разчитам, че сте слушали презентацията на Дженифър. Това е хит. Членове от нашия институт участваха в създаването на програмата по Artificial Intelligence for Smart Growth 2020-2030 и в института има значително количество експерти в областта. Така. Паралелното програмиране, дали ще бъде Multi-Processing Language или ще бъде Message Passing Interface, в институцията има цяла секция, която се занимава с паралелно програмиране и с алгоритми за разпределяване, за ефективно използване на суперкомпютърните системи. Така. Също така в институцията, която представлявам, има и секция, която развива два центъра за Security за Defense Management, за Joint Training Simulation и Analysis Center и те могат да осигурят киберсигурност за всички потребители, които ползват в частния сектор услугите от нашата суперкомпютърна техника и приложенията им. Така. И най-накрая две думички. Всъщност тук вече много говорихме, но в нашия институт има значителен опит натрупан в областта на Precision Farming, моделиране на климата, Emergency Management, което естествено може да помогне на всеки, с което знание можем да помогнем на всеки потенциален потребител, който се нуждае от помощ. Благодарности към колегите, които ми помогнаха преди изготвянето на тази презентация и се извинявам, че закъснях с 15 минути. Thanks.
Thank you for your presentation. Все пак, тъй като сме българи, ще продължа на български, въпреки че имаме и английски колеги, т.е. англоговорящи колеги. Имаме, доколкото виждам, един въпрос, не знам дали е към вас отправен. Виждам професор Ананиев. Може би има някаква грешка, тъй като става въпрос отново за Авитохол. Ако искате, може да отговорите наживо в сесията или след съответно презентациите в писмен вид.
Преценете, ако е необходимо всичките хора да разберат, ако това касае 61 човека, колкото присъства в момента, ще отговоря на живо. Ако касае само професора, ще му отговоря индивидуално, ще се свържа с него. Няма